UAVs, an acronym for Unmanned Aerial Vehicles, have become indispensable in everyday life. Favored by a very fast development in the last years, nowadays UAVs can be bought very cheap on all known online platforms for less than 50 euros. UAVs are getting easier to use as the control system has been enormously improved in recent years by a new control technology algorithm. Furthermore, the user-friendliness is supported by many features. Almost everybody can fly a drone. People just need a smartphone and an installed app on it to control these drones. These apps are available in the app stores of all popular smartphone manufacturers. Then the drone can be easily flown via 2.4 GHz WLAN, including a live view from the integrated camera. Often these apps, depending on the price category of the drone, also provide functions for an automated route input via GPS, whereby an autonomous pass-by of the entered points is possible. The above points suggest that sales are expected to increase over the next few years, as the following study provides. Consumers will buy 10.2 million drones for personal use worldwide this year, according to a recent study by US market research firm Tractica. Sales are set to rise to around 68 million in 2021. This means a tenfold increase in demand compared to 2015. Furthermore, the development continues and first concepts for swarm intelligence of drones have already been presented. Thus, UAVs can also cause damage and threats to the daily life of people, how the incident in London Gatwick in December 2018 showed. In this incident, UAVs had caused an interruption of the air traffic for almost 3 days. The flight security of the airport has seen plenty of drones flying next to the airport. The airport had to be closed several times, and more than 150,000 people were stuck at the airport in the pre-Christmas traffic. The damage of this incident was running into millions, and the ground personnel was nearly powerless to react. This example underlines the need for a proper possibility of reacting to UAVs, if it is needed. In this video, several systems for counter-UAS are presented. What does counter-UAVs really mean? Counter-UAV systems are systems that are able to detect, follow and intercept drones. These systems are divided into 3 different categories. The first category is detection. The next category is verification. And the last category is interaction. The detection system is responsible for spotting the enemy drones in the danger area, chasing the enemy and sending coordinates to an intercepting system. In the following, different detection methods and their advantages and disadvantages are presented. Acoustical sensors consist of a microphone and a computer. They identify the presence of drones by scanning for the typical sound frequencies on which most drones are known to operate. Algorithms pick out and try to locate devices in the area that are likely to be drones. The advantages of acoustic sensors are that they are high and sensitive and they are very cheap. Also, those acoustic sensors can spot autonomous drones with no. Also, these sensors have several disadvantages. For example, acoustic sensors rely on a library of sounds emitted by known drones and might therefore be deaf to drones not covered by the library. Other noises, like on airports, can disturb the acoustical sensors and overlay with the sound frequency of the drones. And also, the range is limited to the noise of the drones. If the drone is too far away, it just can't be spotted. A radar system emits electromagnetic waves and measures the reflected waves from different objects with an antenna system. The following parameters can be determined with this system. First, the direction and the position angle of the object. Then, the distance to the object. Also, the relative velocity between the sender and the object by using the Doppler effect. Also, the movement of the object with successive measurements. And in some cases, you can even see the contours of the object. An advantage of the radar system is that it has a wide range. Also, the system is independent from weather conditions, and the detection of autonomous drones is also provided. The disadvantages of the system is that radar systems are very expensive and they have a coarse resolution, and an overlap with other signals could be possible, so that the system is unusable. Radio frequency sensors recognize the radio frequency communication between the remote control and the drone. They can determine the position of the drone and even of the user. Also, it can propose which drone is used due to specific radio frequencies of different drone models and communication protocols. The antennas are high sensitive, so they can even spot a weak communication between sender and drone. Also, the system has a wide range because of the high sensitivity. And one big advantage of the system is that the system can determine the position of the drone and the remote control. One disadvantage is that the system could not detect autonomous drones because they normally don't communicate with the sender. They just use GPS. This system is based on a commercial 360 camera system produced by FLIR. The camera is connected to a high-power commercial PC. The software uses image processing based on the OpenCV computer vision library to segment the drones from the background. To operate in real time, this system uses the CUDA library to accelerate the image processing on the graphics card of the computer. After image processing and segmentation, the software provides azimuth and elevation in the camera coordinate system of the found object. Those angles can be received via TCP/IP interface. In this example, 3 drones fly a random path in the range of 10 to 30 meters from the camera. The system can also assign the 3 drones between 2 images. The current disadvantage of the system is the relatively short distance of 33 meters for detection of commercial drones. This problem is caused because of the intrinsic parameters of the camera. This system was a study from the German Aerospace Center at the Institute for Optical Physics in Stuttgart and was a proof of concept on the possibilities of drone detection based on commercial systems. The software and was implemented object-oriented, thus other camera systems could be connected easily. All in all, the advantages and disadvantages of the different techniques show that the only secure solution of a drone detection system is a multi-sensor system. Thus, the different sensors must be combined to guarantee a secure drone detection, even in difficult weather conditions, etc. In the following, an example for an optical sensor is presented, which was a proof of concept of an optical sensor to detect drones. Systems are responsible to disturb the connection between drone and controller, make it uncontrollable, and to prevent the drone from crossing the designated area. In the following, the different interception systems are presented. Jammer disturb the VLAN frequency between the drone and the sender. Therefore, a disruption signal is sent, which is more powerful than the one of the sender. Thus, the drone is uncontrollable, and depending on the drone model, the drone returns to its starting point or lands safely. One advantage is that it's a safe way to disturb the connection between sender and drone. Also, most drones land safely when they are losing the connection to the sender. And disadvantage is that it's ineffective against autonomous drones, and there can be an uncontrolled landing over crowds, which could be dangerous. Spoofers send high-power fake GPS data to the drone. This data can influence the drone's navigation system. Specific fake GPS data can change the flight route of the drone to a desired route, that the drone can be landed on a safe spot. An advantage of the system is that it's even effective against autonomous drones because they get their flight route data from GPS. Also, the flight route can be influenced and the drone can be sent to a desired spot. And disadvantage is the complicated system that needs to be set up, that the drone can be influenced and the route can be changed to a desired way. Trained birds of prey like eagles and hawks are trained for catching the drones and bring them safely to the ground. Therefore, the birds need to be trained for a period of time. An advantage is that birds are very well trained and agile predators. That means that they can fly even more complex routes than drones. Disadvantages are that the drones can be faster than the birds, so they can't catch them. Also, the birds have a short span of concentration, thus the birds can operate just for a short period of time. Also, there can be protests against the usage of animals against drones. The counter-UAS project MITRAS of the University of Würzburg stands for Mikrodrohnenabfangsystem. The project is supported by the German Federal Ministry of Education and Research for 3 years. This project is a multi-component system, thus it consists of different defending possibilities. One possibility is to attack an enemy drone by jamming the GPS signals and WLAN frequency. Also, the system should be able to send stronger GPS and WLAN signals to take the control of the enemy and land it on the ground safely. Furthermore, quadcopters with a net span between those two quadcopters can be started autonomous to intercept a drone and bring it to the ground. Those two quadcopters communicate with each other to fly in formation and keep the same distance to each other. Also, those drones get precise information from a ground station where the interrouter is flying. The goal is to catch the drone within a few seconds, and even high-speed drones should be able to catch. An autonomous coverage of a certain area should be possible just with a few of these quadcopter drone systems. This is a big challenge for the flight control algorithms on board of the quadcopters, because it always has to maintain information flight to tension the net and also react on different interruptions when catching a drone. The biggest advantage of the system is that it reacts completely autonomous, and also it prevents the enemy drone from falling to the ground by catching it. First tests, like shown in the video, prove that the flight control algorithms work very precisely and can react to interruptions. To keep the costs low, the quadcopters are printed with a 3D printer. Another advantage of the system is that it is modularly. The customer can customize its own counter-UAS system on its own requirements. The counter-UAS market is booming due to different fatal incidents in the past. The most effective solution for a defending system is a multi-sensor and actuator system to expunge the disadvantages of the different systems. There are already some systems on the market which are based on multi-sensor and actuator systems. Thus, there is also a big demand for those systems caused by a rising number of incidents of intruding drones in the future. Therefore, the research of universities and companies is very important to guarantee a safe aerial surveillance of events in the future.